I think yesterday class for you people I covered fabric, this cyclone separator, right? This one I covered, cyclone separator I covered. This is used, I'll just quickly revise this, what the cyclone separator. So they, where they will use, they remove the particulate matter. Means particulate matter means what? Uh, all those suspended solids which is lesser than 1.5 meter diameter or 2.5. Any of the thing we call as PM or particulate matter is nothing but your roadside dust particle. So those are the particulate matter. So that is how you will remove it. One methodology I covered that, it's called cyclone separator, I think. So cyclone separator, I think I covered that. So uh, this used to work by centrifugal force, I think, spinning of the gas stream. They used to create one centrifugal force. So that used to create some circular flow like this. So since it was like this, the tank it used to get impacted in the here. So that is how it used to get cleared. I think it's here. I will show you that. Wait, see this. This is how the diagram, right? So because of the centrifugal force, it used to remove particulate matter. Now you will see one more methods, fabric filters. This is one more thing they will install near to industries where uh, some gases will be releasing out. Mainly, what gases? See here, gas. Any of the particular gas like nitrogen oxide, something. If it is existing, we can install this, or any particulate matter also. Actually, if it is releasing in any industrial process, they will install this, and those particle they will, it will arrest. Okay, so we will see that how it will functions. So see how it has some you know filter bags like this. It will be vibrating. So because of this, the particulate will arrest here, is right. It will sieve here, it will vibrating, and clean air will pass to another. So we will see that how it will function. One buffer wall also they will give it here. One buffer wall also they have given here. I think this is the buffer wall. Yeah. So this is how it will separate out. I think I covered that. So we will see what this PDF will tell. So one thing you got to know, they will install in any industries where this particular matter is producing, they will install this. So we will see the removal mechanism. Okay, so what is this fabric filter? Means some fabric material they have installed it here, right? So that is why the name they have given. Just all particles comes out and it will strike here. It will strike like this. Okay, and they will be vibrating. So all dirt gas will be removed in the bottom. All the striked particle will go in the bottom, and all the clean air it will go like this. Okay, so that is the principle. So I hope you understood. We'll read what this PDF will say now. Okay, see here. So they're given some diameter and all micro. This is nothing but fabric cloth. You can say one draw cloth, any particulate entering no 0.5 micro. So it will arrest here. See here, it's arrested here, and clean air will pass through one more side. Since this will be vibrating now, so all particulate will settle in one section, and clean air will go up. Okay, so that is how fabric filter functions. Okay, so what it is, as the name indicates, is the fabric bag arrangement of cloth envelope. It has a bags of this much of diameter and this much of long. It is suspended, attached in manifold. In the bottom, hooper is attached so that all particulate which is collected, it will reach there. So the process they have given in here, see, yes, this is all process they are given. Gas entering through inlet pipe strikes the baffle plate, which causes the larger particle to fall into upper due to gravity. The carrier gas then flows upward into tubes and then outward through fabric, leaving surface of the bags, which requires periodical cleaning by wrapping, shaking, or vibrating. So it will be vibrating, right? So all dust will come in the bottom, and all clean air will go up. So sometimes they will reverse the flow, or they will vibrate more, or they will shake more to clean this. Okay, so that's the function. I will move on quickly what things are there. So yeah, one thing is those two things I have done. This advantage, disadvantage, you try to read. Application means where and all it is applicable. Industries, in metallurgical industry, foundries, cement, chalk, lime plants, they will use this thing. Okay, next one more you have electrostatic precipitator is very important. Wait, I will try to go. Yes, so electrostatic precipitator. So you know the terms electrostatic precipitator means something it is arresting due to electricity. The name itself will tell some electric energy, electric potential will generate that will helps to hand or arrest any of the particulate or any of the pollutant discharging in any industry. Okay, so how it will looks, first I will tell general way. See here, they are creating some potential and difference here, right? So what two electrodes they have placed? When two electrodes are placed, some potential difference you will see, right? Here the two electrodes you're seeing, one is here, one more is here. So it's arresting some, it's creating on electrical potential. Because of that, what happening, particles are charging, and some particles are collected here in the electrode, and that is nothing but oppositely charged charge plates. Because of that charges attraction, it will collected here, all particles they will be collected here, and clean air will pass through this. Okay, so the potential difference makes all the particulates to collect and be there in the electrodes only. Okay, that is the principle. And clean air, obviously it will move in the upward here. Clean air will move upward. So this is the function. So we will go through this PDF now, what this tells. Electrostatic precipitator is one of the most widely used in where and where in cement, paper mill, oil refining. It's a physical process by which this is a process up to here. Physical process by which particles suspended in gas stream are charged electrically and under influence of electric field separated from the gas stream. So I already explained in general way. You go through all this thing. This is nothing but what and all it contains. The figure, it has high voltage, discharge electrode, inlet outlet gas, electric cleaning system. You go through all this thing. Concept, I think I already told you. This is how it looks. Don't write this figure in the exam. Just write this one. So see here how it will be seen in the industries. This is all you're collecting electrode. They will install like this. If you see the cross section, it has nothing but so much of electrodes only, right? So here dust air is going in this side. Wait, I will unlock it. Yes, so dust air is going like this. But when you cut this into pieces, you're seeing what this electrodes, lot of electrodes. So they are arresting each of the particle. Okay, it's moving like this, and it's moving like this, and clean air is coming like this. So all electrodes, so many electrodes they have installed. So this is how it functions. Okay, the concept is what? The electrodes made up of oppositely charged, so obviously they will attract each of the dust air particulates, and clean air will be passed like that. Okay. So one more you have. Actually, there is a two types of this electrode precipitator. Those things you don't need. You just read this one only. This is enough. They are classifying this actually. They don't ask this. Pipe type ESP you have, and okay, wait. Yeah. So you have pipe type, and one more you have closed. One more you have, wait, plate type. Plate type and pipe type. Two types are there. You don't require this. Directly you study the next thing important, but you study all this advantage, disadvantage. These are all important. What are all it removes, and what are the problem we will face, like initial cost, space requirement. Okay, those things you read. Okay, they just classified this either pipe type or plate type. It means the electrode, if it is in pipe type, or it might be in a plate type. So plate type, it will look like this. See, this is all plate type, uh, and this is all pipe type electrodes. Okay, so it's nothing but the configuration of electrodes. So you go through this. I will quickly go to next concepts. So this wet scrubber is also important, or wet collectors. So one more concept is there, wet scrubber or wet collector we call. What is this then? This device utilize a liquid called scrubbing liquid, such as water, to assist the removal of particulates from carrier gas stream. Means it will utilize some liquid like water, and this will help to remove any particulate gas or carrier gas which was there. Okay. So how much it can remove means zero point 0.2 micrometer in diameter to up to a larger particle suspended in the gas. Up to that it can remove. So how it will do that mechanism, collection mechanism they have given here around 4 they have given. Impingement was first thing. What is impingement? Here gas containing dust is swept through an area containing liquid droplets, from where dust particles will impinge upon droplets. Once they adhere, they will be collected there. That means since it's a liquid, right? So all gases try to impinge upon droplets or on the liquid which was there, like water. So they will try to impinge on the liquid available. Once they adhere, they will be there, remain there only, and we can collect it back later. Next, you have one more type, like interception type. This is particulates moving may not impinge on droplets. Sometimes if it doesn't adhere or impinge on droplets, but it can be captured because of the brush against the droplets and adhere there. This is called interception. Means if it is not impinged there, then but also it will try to adhere by the process called brush, or any of the uh, going against to the droplets, it will adhere there, even the liquid not in an impingent, not so adhesive. It, because the particles anyway going to that liquid, right? So that is interception they're calling. Because of that also we can reduce. Next you have a diffusion. Diffusion means disperse solids into liquid medium. It's a two phases happens here, solids and liquid. The dispersed phase is solids and dispersed medium is liquid. Just like your Colgate you're seeing, no. So it's a diffusion. So all particulate will be diffused. That is also one method. Next you have condensation. Condensation of liquid medium vapors on the particulate increase the size and weight of particulate, which can be easily removed. Means condensation means what? We're going to condense the liquid, okay, vapor, or the any gas. So obviously size, weight of will increase, and after that we can collect it and remove. Okay, so all the theory they have given here. Mechanism means any four mechanism, it will fall. Any of the four, it will fall, and that is how, because of the impinging, this wet scrubber removed by those that liquid that they provided. Okay, so now what are all the types available in the market? You have around 4 to 5 types: spray tower, venturi scrubber, cyclone scrubber, like that. So yeah, so all works in the same fashion only, same theory. Okay, so just see how the liquid is passed here. So that what making difference here with respect to spray tower. If you see the figure itself, the particulates are settling here. Inlet of water will be sprayed like this. If the spray nozzles is there, because of this liquid, the gases are coming now. It will be arrested. The particulate will be arrested here, and pure gases will pass. So that is the mechanism. So spray towers is the simplest type of wet scrubber in which water is introduced by means of spray nozzles. It can be either round or rectangular, which gas passes, counter current, falling drop, liquid, with sprays, nozzles, the particular can be done by mechanism. So same mechanism, same like interception we have gone through now. So that mechanism only, it will be removed. Here the methodology is what they are supplying the liquid in spray. Okay, so that is the term they are given as a spray tower. Next one more, you have venturi scrubber. What is this? So venturimeter you have studied in the fluid mechanics. It's similar to the shape, that is why they're given. So we will go through this then. They are high energy wet scrubber with high performance collection fine particle up to 0.5 to 5 micrometer diameter. So here how the droplets are arrested. The droplets accelerate throat section. Throat section means this section. You're seeing now. This is called throat section. The droplets accelerate means all the droplets will come here in the throat section. Due to the velocity difference between particles and the droplets of the particles are impacted against the slow moving particles. So there is a liquid also there and gases also there. So there is a difference in what particles velocity which they are coming. Okay, so there is a difference because of this. The all the particular particles are settling. Okay, so that is the concept. Up to here you remember and write the figure. This and all you don't require. So I will move on to one more cyclone scrubber. It's also same phase. It works in the same principle. Okay, wet scrubber means some liquid will be there. It will be arresting. Okay, so how it will looks is like this. See here, water in, water out. Spray. How they are spraying the water. There is a straightening veins is there. Water is coming here. Water is going here. But here all dust is coming. Water they are supplying from the bottom and dust is parallelly there. It is going. So a lot of mixing is going here. Here clean air is passing like this. Okay, so we will read this now. Cyclone scrubber, it's a modification of dry cyclone by addition of liquid phase. Cyclone scrubber, the gas is tangentially filled around the same dry cyclone. Water sprays from the top of the cyclone and outside of the wall. This spray assist. This is important mechanism. This spray assists the collection of the dispersed and prevent re-entrantment. So it will arrest their telling or prevent the entertainment of the particulate matter. Okay, so that's over. Anyone they might ask, or you just have to study the diagrams. After that, you can write on your own. Because once you remember the diagram, you can just try to elaborate that. Okay. Okay. So one more, you have packet scrubber. And what else is there? Yeah, this is the last, I think. Your fourth model, this is the last topic. Packet scrubber you have. We will see that what it is. Packing is there. Yeah. So liquid is passing like this. Some packing material is there. Here you're seeing the figure now. Seeing the figure, you can observe what happening here, because since you know the concept is nothing, the liquid will be there. That is going with all the four mechanism theory. Yes, interception is there, uh, impinging activity is there. So any of the thing, it will fall and it will remove. So that is the theory. You already seen here, right? Theory you have gone through in the first only. See, impingement, interception, diffuse, and condensation. Any of the four methodology will be there in all the scrubber. Okay, all works in the same principle, but it's just how they will made it that's making the difference. So last one thing is remaining. This is packet scrubber or packet tower. So I will try to do that now. Okay, the packet scrubber or fiber glass or fine glass filament or other packing, uh, or means they are creating some material here. Packing you are seeing now. So it has made up of some materials. I'm reading now. See this? It made up of what? Some fiber glass or fine glass filament or any coke or broken stone. Okay, the material they'll fill it here. Okay, so the polluted gas stream moves upward in the counter current flow packet scrubber and comes in contact with the scrubbing liquid. Yeah, see here, gas is coming like this. Gas flow is happening like this, and it will come in contact with spray is already supplied in the top. Liquid they are supplying like this. Wait 1 minute. Yeah, see here, our gas is entering like this and liquid are passing like this. Okay, so there is a packing material made up of some glass or any filament. So because of this adhesion thing, all particle will be arrested here. Okay, so and all the clean gas will be gone like this. Okay, so that is all what they are explaining in the PDF. See here. Yeah, here the gas stream from here it starts. The gas stream passes through the packing pore space and captures particle by inertial impaction. Because of good mass transfer characteristics of the packing, efficient collection of the fine particle by diffusion also possible. The third methodology you have studied now diffusion, and already you know impaction. The second or interception, that also. So any of the four thing, two things are going here because of this two theory or any mechanism. These gas are removed. What are the mechanism? By diffusion and inertial impaction. So because of this, the gas particulate are removed. Similar packing increases the efficiency of the collection. So additionally, they are speaking means more packing of the materials of this fine glass filament or any other coke or broken stones. We can increase what efficiency in the collection, but its shape does not appear to affect the collection. Means shape is independent. Shape it might be anything. Okay, so sometimes packing towards encounter plugging problems which can be reduced by employing sprays to wash the packing or by using low density spear. Means some plugging problem might be there, so that is why they are supplying constant liquid or spray. Here they're supplying this spray, so that will eliminate any of the problem that might arise. Okay, so yeah, so that's about packet scrubber. What else you have? Mechanical scrubber, one more is there, last one I think. Mechanical scrubber also there. So we'll try to see that here. What is mechanic? All our works in the same principle. Around 5 to 6 years study. No, it's the same theory. Some liquid will be there, and some at the end you have came out some packing material they are designing. So both combination, all particulate or any pollutant which is in the air, it is disappearing. It is arrested by that. Okay, so we'll see last one is scrubber. This only. What is the mechanism they are talking about. What is the mechanism of this scrubber? Okay. Okay, so it is a high energy scrubber. Mechanical means breaking of scrubbing liquid into small droplets and simultaneously creating turbulence. So one more high energy scrubber you have, wet scrubber we call. What it doing here, it's breaking up the liquid into small droplets. Whichever liquid we are using here, no, it will break that into small droplets, and with doing that, it also create turbulence. Okay, so means turbulence will be created by those droplets. Those droplets also breaken into small part. So internal rotation mechanism part where liquid disperse contact is achieved by simultaneously introducing the liquid medium and gas stream. So since this turbulence is induced here, and simultaneously they're creating these small droplets into breaking. So because of that, combination of this gas stream and liquid happening, and because of that, all the particulates we can remove. So the scrubbing of liquid drip ripples down on the rotating part of, and is struck violently and disintegrated by centrifugal force. So centrifugal force, if it is introduced, we will arresting the movement also. Once the centrifugal force we have introduced, no, how this force is moving, like that only all the deposition of the particulate matter happens. So that is here, the by centrifugal force are removed quite easily. These scrubbers have high initial cost. This all advantages disadvantage they are given. High initial cost, high operating cost, and require considerable maintenance. Okay, so this is all you go through. Advantage and disadvantage. Okay. Yes. Okay then. I think this fourth model I covered. This advantage, disadvantage, you go through this. And I think any one question I will ask in general, any of the one here. And this one also I will ask. Okay, last 10 minutes left for me. I think I covered most of the fourth model. Particulate matter, I covered cyclone and gravity separator. These two things I already covered in the last class. Today I had done what the fabric filters, means nothing but the fabric cloth material which was there. It was rusting. That I covered. Next, I thought about what electrostatic precipitator, because of the potential difference electrostatic created. These electrodes made up of oppositely charged of the particulate which is entering. Because of this attraction, all particulates are collected here and clean air is going. This I covered. And this how, what are the types? I think I covered plate type and pipe type. And after that, what I covered, I thought about more on this scrubber. Any one scrubber they might ask. This all five I think I covered. Okay. So today up to that this much only. Tomorrow I try to do fifth model. Okay. This is very less to study this model. Very easy. So go through it. I think I'll end the session. Is it okay now? Hello, Gonasri. Are you there? Hello, Revan, Shahid, Afrid. Okay.
Yes, sir.
Okay, I will end the session. You go through all this thing. Okay, I will send the video. I think I recorded the video. I will send the video also. Okay.
Okay, sir.
Okay.